Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in this Pure Math 1 video, which is known as P1, we are focusing on trigonometry. And in trigonometry, I want to focus on something special. And that special thing is about working with clockwise angles. We always work with anti-clockwise angles. We know that anti-clockwise angles are positive, therefore clockwise angles are negative. Now let me label some angles over here. For example, let me label this thing as 30 degrees. Let me label this thing as 110 degrees. Let me label this one as 240 degrees. And this one, let me label it as 300 degrees. So basically, I have labeled the red angles. So let me just change the color. And this one is red. This one is red because all the angles that I have labeled anti-clockwise, these are red angles. So let me change the color and let me change the color. So now over here, if I've labeled these angles in red as anti-clockwise, what is the opposite? So now let me grab my blue pen. Let me start from the x-axis, the horizontal positive x-axis, go all the way like this. This is simple subtraction. 360 minus 30 is 330 degrees, and let me write clockwise. But since clockwise angles are negative, so technically this is negative 330 degrees. Understand this very, very carefully. Similarly, again the positive x-axis, that is where we are measuring the angles from, whether clockwise or anti-clockwise. 360 minus 110, that is 250 degrees clockwise, which can be written as negative 250 degrees. Similarly, again positive x-axis, we are going this way. This is 120 degrees clockwise, which becomes negative 120 degrees. And similarly, this is the positive x-axis. We are going this way. That is 60 degrees. That's the difference clockwise. But 60 degrees clockwise is the same thing as negative 60 degrees. So let's zoom in and let's double check. That's the relation between clockwise and anti-clockwise. If you have the anti-clockwise given, just subtract this angle from 360 degrees and later on change the sign. As simple as this. Now let's move ahead. Let's solve this question. And this is one of the very, very basic questions which I have solved many times, but there is a particular reason for it. So now we apply the 4-step method. That is, first thing, it's about the quadrants. So we are talking about first and second quadrant. Why are we talking about first and second? Because sign is positive in first and second quadrant. That is the first step. The second step, that is the range. It's not changed. It's not modified. So just copy paste this thing. The third step, that is let alpha be the basic angle. Sine of alpha is 0.5. Therefore, alpha comes out to be 30 degrees. Basic angle is the acute angle with the x-axis. So now we know that in the first quadrant, theta is alpha. In the second quadrant, theta is 180 degrees minus alpha. So now this is pretty basic. So therefore, theta or x, that is equals to 30 degrees. 180 minus 30 is 150 degrees. That is the simple basic answer for this particular part. Similarly, let's do example 2. Now this is the real thing. That is, now we would be working in clockwise angles because we are starting from 0 and going all the way till 360 negative. This first question, that was as usual about the anti-clockwise angles. Anti-clockwise angles are positive. And we know that clockwise angles are negative. Now it's the same equation as before. What have I changed? I have simply changed the range of values of x. That is changed. So let's see. Let me just copy this thing from here. And let me just copy this whole thing like this. So it's very easy to do this. Of course, you cannot do it on the whiteboard. And I have pasted it over here. Now let me draw some angles, and let me choose a green color, and let me draw this line like this with this thing. That is one angle, that is the other angle. So now the red angle, that is the clockwise, anti-clockwise angle. This is 30 degrees. That is the red angle. Let me change the color. So that is the red angle, and this angle is 150 degrees. Got the idea? So now what are the clockwise alternatives? The clockwise alternatives are this thing, that is 330 degrees clockwise, which can be written as negative 330 degrees. Over here, this one is a 210 degrees clockwise, which is written as negative 210 degrees. Of course, we are measuring it with the positive x-axis, whether clockwise or anti-clockwise. So now the answer is x is equals to these two angles, and that is how this question is done and dusted. Now, what is the special thing for which I'm making this video? The purpose of making this video is to apply the concept of trig sketch over here. Now, first of all, when we talk about a sine function, we can talk about cos, we can talk about tangent, and so on. So it's a periodic function. That means it completes its waveform in a particular length, and that length is 360 degrees. So I can say one cycle is completed in 360 degrees. So let me draw a nicer version of this one. So therefore this goes like this, and this goes like this, and that is like one cycle. So it's going starting all the way up till here. That is one cycle is 360 degrees. There are 5 major points which we have talked about in class. Those 5 major points, let me label it. First of all, first draw, then label. So this is 0 till 360. The maximum occurs at 90 and the minimum occurs at 270 degrees, and there is 180 degrees in the middle. So this is the first quadrant, second quadrant, third quadrant, fourth quadrant, maximum value 1, minimum value negative. Now the same graph is over here. What is special about it? The special thing is what I'm going to do right now. Let me grab this thing and let me just switch it like this. So now what exactly have I done? What I have done is this thing. That means I have drawn it from 0 till negative 180 till negative 360 degrees. So basically it's a waveform. It's going like this and like this and like this, and this is on the right hand side of the y-axis. This is on the continuation on the left hand side. So far so good, all clear. And then again you can see that now the maximum is occurring at negative 270 degrees and the minimum is occurring at negative 90 degrees. The maximum is 1, minimum is negative 1. So this is also y is equals to sine x, but x lies between 0 degrees and negative 360 degrees. The one at the top, that is x lies between 0 degrees and positive 360 degrees. Now let's join forces. Let's apply the concept of trig equation. Worked example 1, worked example 2. With these two, let me draw the sketches. So another perspective. So now the first one is that x lies between 0 and 360. That's already drawn. And let me label it. So therefore this is 360 degrees. This is 0 and all these things. And let me take this blue line and let me just remove this thing. Let me take this blue line and fit it in over here. So what is this blue line all about? Of course, this thing, the sine x that we have drawn in red, and this one is basically y is equals to half. This is y is equals to half. That's over here. The red one, that is y is equals to sine x. So this is like graphical solution of equations. Drawing both on the same grid, the number of points of intersection will give me solution of this equation. So now we already know the solution. That is worked example 1. What is the solution? The solution is 30 and 150, and we can very well see it from the graph. So over here, let me mark it in green color. This value over here, this is the first answer, that is 30 degrees, pretty realistic. And this is the second answer, that is how much? The other one, that is 150 degrees. Why? Because this one over here is 180 degrees, this one over here is 0 degrees. Now there is something else I want to focus on. Look at this gap, that is of 30 degrees. Look at this gap, that is of 30 degrees. That means if I label it like this, this is 0 degrees, this is 180 degrees, somewhere here is 30 degrees, somewhere here is 150 degrees, right? So what is the gap over here? The gap is of 30 degrees. What is the gap over here? That gap is also 30 degrees. That means you can see beautiful symmetry in the graph of sin x related to these solutions. There are two solutions, and that you can see it over here. Now let me focus on this one. That is the second worked example. Sin x is equals to 0.5. X lies between 0 and negative 360. We should also be getting the same solutions from the graph. Let's have a good look. So that is the first perspective. Now the second perspective. So let me write over here. This is basically worked example 1 revisited, and when I revisit it, I am applying the concept of sketch. And this is again worked example 2, again revisited, and we are revisiting it for the help of a sketch. So now again let me first label it. So therefore that is negative 360 degrees, that is negative 180 degrees, that is 90, let's ignore that, and I'm interested in this one. So now let me just fit this thing over here, okay, and let me just move my logo over here. So now this is the blue line, that is y is equals to half, and the red one as usual, that is y equals to sin x. How many points of intersection? 2 points of intersection. Now let's look at the solution. The same symmetry should be there. That is the difference of 30 degrees. The difference of 30 degrees. So 30 degrees before negative 360. This one is negative 330. 30 degrees after in this direction. That is negative 210. And that is exactly the same answer. So now over here, let me label it. This is negative 360. This is 0 degrees. 30 degrees on this side, that is negative 330. 30 degrees on this side, my bad, this is not 0, this is 180. Basically, we are working from negative 360 to negative 180. We are focusing on this one. And in the previous one, we were focusing on 0 till 180. So 0 till 180, 30 degree difference, 30 degree difference. Now this one is negative 360, this one is negative 180, again a 30 degree difference. So therefore that is negative 210. So there is a difference of 30, there is a difference of 30. And again, what do you see? You see a symmetry over here. So now so far so good. Now worked example 3. What is this all about? So worked example 3, this time I'm flipping the technology. And what exactly technology am I flipping? That is this time, let me first work with sketch. So let's start working with a sketch. And of course, I'll be applying the concept of symmetry over here. So when I talk about sketch in relation to this, I'm talking about symmetry. But wait a minute. There is also one other thing that I need to write down. So let me write down over here. That is y is equals to sin kx. For that matter, this is also applicable to y is equals to cos kx. Of course, for tangent, it's different. We know that k cycles in 360 degrees. That means y is equals to sine 2x. The coefficient of x is 2. Therefore, 2 cycles in 360 degrees. In other words, if I talk about 180 degrees, that would be one cycle. That's one approach. So now over here, when I look at the sketch, so this is 0, this is 360, 2 cycles in 360, that makes sense. And therefore the mid value should be 180, and this mid value should be 90, and this mid value should be 270. Now let's first just focus on the red part. That is one cycle, the blue is the other one. The maximum used to be at 90. Now the maximum is where? So now the maximum, and let me draw it straight, hold for a second. So now the maximum is occurring at 45. The minimum used to be at 270. Now the minimum is at 135, and similarly it will change over here, the mid value, the mid value. Just focus on these two. So now what else do you observe? Firstly, the maximum y is equals to sine x. The maximum 1 was occurring at 90 degrees. Now if I talk about y is equals to sine 2x, maximum is still 1. But what has changed? The value is now 45 degrees. So that is because of this. 90 over 2 is 45. And if I talk about the minimum, let me just shift it over here and let's double check. So now over here, when we are talking about y is equals to sine x, the minimum is -1. It was occurring at 270 degrees. Y is equals to sine 2x, minimum is -1, but the minimum is occurring at 270 over 2, which is 135 degrees. And that is exactly what is written over here. Basically, in a shorter space, you are compressing it. So therefore, since the compression thing is because of that 2, which is the coefficient of x. I'm not talking about scale factor or anything at the moment because I'm not teaching functions right now. So therefore, this x-intercepts are divided by 2. The 180 becomes 90. The 360 becomes 180 and so on. Now let's apply the same knowledge. And that knowledge over here is that, let me take this green line and let me just remove this. Let me take the green line and let me place it over here. Okay. So now, first of all, when I talk about this green line, so I am drawing y is equals to half. So this is y equals to half. And this blue and the other color, that's red. These two, this is y is equals to sine 2x. Now, first thing first, how many points of intersection do you see? You see the first point, the second point, the third point, the fourth point. And now I can claim that this difference is no more 30 degrees. This is 15 degrees because every x value has been reduced by a factor of 2. So therefore, let me write it over here, and there should be a line over here. So let me draw a line over here like this. And first of all, let me choose this thing. And let's see, what do we see? So now we have this thing as 0, this thing as 90, and this thing as 180. Just focus on these two for right now. So now this difference is 15 degrees. This is 15 degrees. So this is 15 degrees and this should be 75 degrees. Similarly, over here, again, this is 180 and 270. So let me focus on 180. Let me focus on 270. And again, there is a difference of 15 degrees and 15 degrees. So this is 195 degrees and this is 255 degrees. So there will be 4 solutions over here. Which 4 solutions? 15 degrees, 90 degrees, 195 degrees, 270 degrees. 15 degrees and not 90, my bad, that is 75. So 15 degrees, 75 degrees, 195 degrees, 255 degrees. That will be the coordinates of points of intersection of curve and line. In other words, that is the solution of equation sine 2x is equals to 0.5. All good, all clear? Now let's double check the result. Let's solve it out using the normal means. Now first of all, sine is positive, therefore we are talking about first and second quadrant. That is one thing. The next thing, that is modification of range. X lies between 0 and 360, 2x lies between 0 and 720. We are talking about 2 revolutions. The third thing, that is the basic angle. Sine alpha is 0.5, therefore alpha is 30 degrees. So now let me grab a green color marker and let me label 30 over here. Hold for a second. First of all 30, and then this angle, and then over here, and then this angle. So now firstly we are working in 0 till 720 now. So this is 30 degrees, this is 150 degrees, and basically I don't need these two at the bottom, so let me just erase it. So now let me go one more revolution. 30 plus 360, that is 390. 150 plus 360, that is 510. So let me write over here. So therefore 2x equals to 30, 150, and then 390 and 510. Therefore make x the subject, divide by 2, 15 degrees, 75 degrees, 195 degrees and 255 degrees. Let's double check. There it is, 15, 75, 195, 225. So I have done this question in 2 conceptual ways. One is the equation way, and then one is the symmetry graph sketch way. That's how it's done and dusted. Now let's do this thing. Sine 2x is equals to 0.5. Again, the values are labeled. Sine 2x is already drawn. 2 cycles. One is blue, one is red, but this time this is 0 till negative 360. So now let me grab this line and do the same process as before. So let me just pinpoint this line over here. And again, let me use this thing. This is y is equals to half. That is the flat 0 gradient line. And then this one, the red and the blue, that is y is equals to sine 2x. So this is y is equals to sine 2x. Now again, that 15 degree difference should be there. Why is the 15 degree? Because initially it was 30 degree. Because of that 2, the difference is reduced. And look at this. How am I marking these values? So now over here, this one is negative 360 and then 15 degrees over here, negative 345. This one is negative 270 and 15 degrees, that is negative 285. This one is negative 180 and then 15 degrees, so that is negative 165, and this is negative 105 degrees. So basically there is a gap of 15 degrees. So negative 360 minus 15 is this thing, basically 15 degree difference. And this is 270 and then 280 and then 285, all good. This is negative 180 and then 15 degrees before, that is negative 165. This is 90, 15 degrees after, that is negative 105. The same number line method. Now let's solve this thing using this. Now till now, pause the video, think about it and apply your knowledge. So now remember, anti-clockwise angles are negative, clockwise angles are positive. Now first of all, let's write down the steps over here. First thing first, that is the first and the second quadrant. That is the first thing, and let me just shift this thing a little bit down. So that goes like this, and this thing goes over here. That is perfect. So now first and second quadrant, the second thing, 2x lies between, this is negative 720 and this is 0 degrees. The third thing, what is that? Basic angle, sine alpha is 0.5, therefore alpha is 30 degrees. And now let's start working over here. Let me grab a green marker. Let me draw this thing like this. Let me draw this thing like this. and there should not be any break over here. And again, this thing is like this and this thing is like this. And let me just separate it out a bit like this and like this. Okay, now first thing first, we know that the basic angle is 30 degrees. So therefore, in the first quadrant, this one is 30 degrees. But we are not interested in this one. We are interested in the blue angle, that is negative 330 degrees, what was taught at the beginning of the class. Again, this one is negative 150 degrees. Again, we are interested in the blue angle. That is how much? That is negative 210 degrees. Now let's keep moving in this direction. So basically, this one is like this. That is negative 330. Keep on going one revolution more. So therefore, 330 plus 360, how much is that? That is 390 degrees. My bad. 330 plus 360, that is 690. So 690 degrees negative. 690 degrees negative is over here. Over here, this one is 210 degrees negative. Keep on going more. Keep on adding angles like this. We are going more round the revolution. We are adding 360. Just ignore the negative sign. So 210 plus 360. How much is that? That is 570 degrees. So this is negative 570 degrees. Now all these values are equal to 2x. So let me write it. Which is the smallest one? So 2x is equals to negative 690 is the smallest, second smallest is negative 570, then it's negative 330, then it's negative 210. So now this is when we make x the subject, that is 345 negative, 5628 285 negative, 330, 165 negative, and 105 negative. These are the four answers. Let's double check. 345 to 85, 345 to 85, all good. And 165, 105, this is 165, 105. These are the four answers. So basically, the bottom line of the story is that yes, when we are solving a trig equation, the very first method is that of the four-step solution, and we can also solve it using a sketch, provided the values are such that the numbers are very whole number type of thing, and based upon sketch, based upon symmetry, we can draw the thing and get the answers. So these two ways are two different ways of solving the same thing. Of course, the sketch and the symmetry will work for everything, but when we are dealing with integer value angles, it becomes very convenient. It's a matter of convenience. And when we talk about the famous angles, we are talking about the three angles, 30, 60, and 45. So these are my favorite angles and the trigonometry's favorite angles that are easy to work with. So that was the moral of the story of this whole particular video. Get your concepts very, very clear, because symmetry is something that is very much liked by the examiner, and sketch is definitely the examiner's favorite. Stay tuned for more content on mathematics with Shahab Yaqub.